So once again, I'm saying it for the recording. Please remember to fill up the JCT questionnaire, in Italian CPD, questionario Comitato Politecnico per la Didattica. That's a questionnaire that helps us to plan the course in a better way for next years. If you find any drawbacks, or even if you find something nice that you would like to keep and so on, it gives you a lot of advice for us how to tailor the course in the best way for the students of this course of study. Okay, you have to compile it, fill up it before booking for the exam. I mean, no need to rush because there's no order in the booking for the exam. Okay, because at a certain point there is a deadline to it closes for a few days before the actual exam date, but I mean, since it's required to allow you to book for the exam, I mean, think a little bit about what you can write there, especially in the free text part, that is the most useful one for the teachers. Okay, thank you. Okay, so let's go back to our discussion, and we were discussing the implementation, right? So we were discussing how to implement the TOTP in our application. We modified the database, so we modified it, I mean, together, because actually I didn't know the updated version of the database, but I loaded the updated version of the SQL code. Okay, so that is good, because so you have the code and you know how to run it to create a new database, and you can also write the information inside it here, okay, with some inserts, okay, before you use your database file. Good. We were looking at the server side. It's almost, I think, all is implemented. I mean, the only thing we missed is, I mean, we say don't return the secret when you ask for the information about the logged in user. Let's look for the API. Okay, that's here. API sessions current. That's the one that is called at component mount time, when app is mounted. Let's have a look. Okay. And we say it's for convenience, but also later on. Okay. You see the headers, API sessions current, request, no request body, but the headers are the cookie, right? That's what interests to us. And in the response, you see the username, name, and so on. And you see these two fields which I recommended you to write here, like can do TOTP true, is TOTP false, it means it's not logged in with TOTP. Okay? Of course, we didn't do the TOTP login yet. Okay? The TOTP check yet. Okay, but the point is that make sure that you don't simply return I mean, rec user, as we were doing last lecture, because now rec user contains additional information. Okay, let me see. I mean, the information that it contains, it's in the DAO user. It is yes, here I think. Get user by ID. It contains the secret and the last TOTP step, okay? In addition to, here we don't read the hash, that's good, okay? So, how do we avoid returning this stuff? Just make sure you avoid returning it. I mean, we said in the slide, just define a function. I mean, this function just takes the user and it creates a new object and just takes the stuff that is needed. The ID, username, name, first name, last name, whatever you need. And then can do TOTP. Okay, is the secret set? Yes, true. Otherwise false. That's a possibility. If any user can do TOTP, I mean, this field is not really needed, right? And is TOTP instead is very useful because it says if the actual session has already been authenticated with TOTP or not. Okay, so since we reloaded the application, right? We reloaded the application. We are signed in. If you already performed the TOTP, that means that we trust this session ID, that is the cookie, also for doing actions like the delete in our example that require the TOTP. Okay, at the moment, I mean, we are not enabled to do this action. The check is always performed on the server side, but the fact that we enable or disable this button can be done on the client. Okay, actually at the moment on the client that's not done, but I mean now I should disable these buttons as well. Okay, and I will do it in a few minutes. Okay, good. I think we saw status and so on, or GPD, we already talked about it. And so let's go to the client. Okay, client. So here we don't need any modification. Let's delete the stuff that's not needed and make sure it's the correct file. Yes. Okay, so let's go to the state. Is logged in. We said let's keep the state of the TOTP, right? Const logged in TOTP get in TOTP. Use state false. Of course, in the beginning we are not logged in, right? TOTP. Okay, and then we simply use it. Okay, we use it where we have the login TOTP. So basically we need to pass it to the components that needs to know if we are logged in or not. Okay, I like to show it show the status in the top bar as well. I mean in the header. Because it's so useful for debugging as well. Okay, so let me check. I mean the layout. Yeah, login in TOTP. That's for later. Layout. Definition. Okay, in my header, logged in TOTP. And my header is defined, implemented here. I think we can do it log my header. Yeah, I mean, we can just change what we write, right? Signed in as, I mean, signed in, I think I brought something like this. I open a JavaScript scope since it's a template literal, okay? Logged in with TOTP or not, I mean, it's so too long, I don't like it. 2FA or not, okay, as. Of course, now I am not, so nothing changes, but as long as I will log in with the TOTP, this will be shown up here on the top right part of the application, okay? Good. And let's do the form. Okay, we need to create a form where we can type this value. Okay, and where do we put the form? Actually, after I log in, I want to be presented with a form with the TOTP. Okay, so I need to implement a form. Luckily, I already did it. Okay, so we have an Auth component. And there is already a TOTP form. It's pretty easy, right? TOTP code, it's a controller form component, so on change, set TOTP code, event target value, nothing really special here, just copy pasting from the usual stuff. I just wanted to handle the errors, and so, I mean, set error message, there's a service state that you set, so you can show an alert when there is an error. It means that the TOTP code is not accepted and so on, okay? But I mean, in principle, it's pretty easy. TOTP form is already exported. No, we need to export it. TOTP form, okay, save it. We import it in app, login form, TOTP form. And then we can use it. How do we use it? Well, my recommendation is I mean, it's just a possibility. I mean, it's not mandatory. I have seen many different ways of implementing it at the exam. All of them were valid, okay? But, I mean, my recommendation is to change the component that we show on the login path. I mean, we can have the same path both for authentication and the TOTP. Depending on the state, we decide which one we want to show. Another possibility is to have different routes, /login, /login TOTP. But then you have to redirect between one or the other and so on. It might become a little bit more complex. It's possible. I mean, not really so difficult, okay? But I mean, that's one of the possibilities I'm showing you, okay? So, actually, there's no, so that means that, I mean, we change this stuff, and I create a new component, login with TOTP, login successful, okay, that's the function I need to pass, and then I need to pass the logged in status, because I need to decide what to show, logged in. I need to pass the user information, I think. If it passes too much, then we can delete. And the logged in TOTP, okay. Set logged in TOTP. Set logged in TOTP, okay. Still to be written. And that's all, okay. And then, oh, by the way, with respect to Monday, I did a small modification. You see, if I'm already logged in, I render a component which is called navigate, replace to slash. So basically, when you are on /login and you're already logged in, the system recognizes it and it sends you back to /, which is the home page of your application. Okay? I mean, that's not mandatory. I mean, you could just ask again for the login, but I mean, not so nice, right? You're already logged in. The application knows you have a valid session because the state already tells the application you have it, and so I mean, why you should stay there? Okay. Okay, good. So I mean, we can delete this one, oops. And we need to implement this function, right? Function login with TTP. Yes. Yeah, you can write a better way, okay? Let me copy paste because it's a bit long. I think it's in client, source up. I already have it because I already prepared the solution, of course. Copy and paste it. And now we read it and try to understand it. So my idea is that there is a single component that is rendered under /login that decides what to render. Okay? If props logged in and the user can do the TOTP and it already did the TOTP, I mean, we have nothing to do. Navigate to /. If can do TOTP, but so it's logged in, can do TOTP, but it didn't do the TOTP yet, let's show the TOTP form. Okay? TOTP successfully, just set logged in TOTP true. Good. Else is it cannot do the TOTP. I mean, there's no need to show the TOTP form. I mean, of course, I mean, it cannot use it. Or if it's not yet logged in, that's a login form that was originally implemented. Okay, in the solution from which I started today. Okay, so that's the idea. That's the possible cases, right? We have the possibility to use TOTP. We prefer the TOTP. Otherwise, we show the form. Otherwise, we don't show the form. And if we are already logged in, we go back to check if the TOTP is enabled and already been done. If we are not logged in, we show the login form, username plus password. Okay, that's the idea of this code. Because you can do it with the redirect, with /login TOTP and so on, a possibility, but you need to think in terms of routes and redirects and so on. It becomes a little bit more difficult in my opinion, but that's just my opinion, okay? Another option at the exam that I've seen a lot, and it's correct actually, is just asking for performing the TOTP login when the first action that requires the TOTP is required. That's another possibility. So you decide to show the form, but it complicates the design of the application much more, because you need to think in terms of all the action that might require TOTP, do a redirect, and then come back to the same place to perform the action. So it's much more complex. Still valid, but we'll try to go for the simplest solution. Okay? Good. So this should already work. Okay, so save. So now restart the application. Okay, we are signed in, so I don't like it. We log out, restart the application. We have no other ways. I mean, otherwise we go and delete the cookie, right? Login, I think, I mean, Harry was not enabled, I guess, for the TOTP, so it's not a good choice. Let me check the server, QADB users. Oh no, yeah, Harry is enabled, so there is the secret, right? Okay, good. Sorry. So click on the login, right? Login, it will perform the authentication. So the post says response OK, 200, OK, response with the information, can.TOTP true, is TOTP false, not yet. Please enter the code that you read on your device. I mean, write whatever you like. Which is the code? Actually, this is the code, okay? Of course, I should read it from the other device, okay? But I want to have it in the recording, so I need to put it on the screen, okay? That's the code, 802.956. 802.956. Click validate. That's a submission. You see the post, and the post goes to /login API/login TOTP. That's a route I designed on the server, so it's an API on the server that sets the, validate token and so on, and then stores the last step that corresponds to the value I just used, and then it says rec session method TOTP. Okay? Good. So now I have a session which is TOTP enabled. So I can try to do the delete. Okay? Let's try. Okay, this time was successful. So things almost worked, right? Oh, by the way, you see the 2FA here, okay, on the top right. So we also have a state in the application that says we are TOTP enabled, okay? That we set when we receive the correct, the OK from the API from the server when we send the code. Okay, well, delete 200, okay, that's fine. Okay, so let's go back to the code. Code is here. So props login successful. No, that's for the credentials. TOTP successful set logged in TOTP true, so it immediately sets the state in React. Okay? You just need to remember that when we log out, of course, the server, okay, log out, log in. The server, you see, 2FA, it's not true. We forgot to reset it because, you see, it doesn't work. We need to make sure that we handle the states in React correctly. So when you log out, set logged in TOTP false, okay? Don't forget it. But you test the application a little bit and you discover these issues, okay? Good. The other point was client TOTP station. Okay, disable the buttons, right? We wanted to disable the buttons, so not log in. Okay, I can do cancel, okay? I can do cancel, it goes on, well, I forgot to reset the state, sorry. Okay, and I'm logged in with the username and password, but not with the TOTP. And this button should be disabled. Okay, indeed it doesn't work. Okay, so in short, I mean, that's up to you. If the user has the option to continue without providing the code for the TOTP, so has the option to go on without the second factor authentication or not. I mean, most of the websites says you cannot do anything because we want a stronger authentication, okay? But it's up to you to decide, okay? So this application has, you know, all the cases implemented inside it. But I mean, most of the applications like Google, Gmail, GitHub, and so on, at the first time they want you to have this second factor authentication checked, okay? Why? Because it's so easy to impersonate somebody else just knowing the password, right? So, I mean, today they think it's more appropriate to always perform the second factor authentication. But again, it's up to you, okay? So cancel could send you back to, to a page that says, well, you cannot continue without performing second factor authentication, or maybe simply, it's not so nice not to have anything to navigate away from this page. So, I mean, you should allow the user to say, oh, okay, I was wrong, but I mean, if I press cancel and actually the second factor authentication is required, maybe you have a page saying, okay, actually you should perform second factor authentication, otherwise you cannot continue. That's a possibility, okay? Good, so let's go back to the application and just check, just modify this behavior of the button, but it's quite trivial, right? I think, yes, I implemented here another property. I called it disable TOTP action. Disable TOTP actions. Okay, which is not like this. It's not logged in TOTP. Logged in TOTP. Okay. So if I'm not logged in TOTP, I want to disable TOTP actions. Okay, just the meaning. Okay, otherwise we say enable, and you can write logged in TOTP. So this is answer route. So we need to go to the answer route. This is sort of trivial, right? So that's the answer route. Disable TOTP actions. Offline. Why? Props disable. No, keep suggesting, so we're still online. Answer route. Here it's the answer table. So boring, right? Passing all these states. Again, this is something that could go into context. Disable TOTP action. Again, save and answer row. Now we use it. Answer row. No, sorry, answer actions. And now the delete, right? It's a delete. Disable or props disable TOTP actions. Okay? Save. What was here? No, the edit is okay. Okay, so I don't accept the suggestion. What's wrong here? Expect found answer component 71. I mistyped something. What's wrong? Yeah. 71. Disable TOTP action. So what's wrong here? Yes, there is a missing. I guess. No. Props. Let's see. So this closes this one. No, this has to close this. This is miss. Yes, here, right? Yes, should be. Okay. I mean, it's just a matter of parentheses. I mean, it's so boring, but unfortunately they have to be correct, right? Okay. I'm signed in as Harry, but without the TOTP, right? I mean, let me check. No, so it should be disabled, right? I mean, I don't know, I debug, okay? So, unfortunately there's no name, but this is the last state, right? Logged in TOTP. I think it's the answer actions, disable user, disable user action. It should be disable TOTP actions, right? So something is missing. Disable TOTP actions, true. So answer role, it's okay. Disable TOTP action, answer role. And that's the answer role. I should pass it here, right? Disable TOTP action. Okay. And then we get it there. Okay, now it's disabled. Okay? You see the context is sort of your friend sometimes. Okay, so and so I cannot send a request. But the security is not here. I mean, this is just convenient for the user. Convenience for the user, okay? The check is done on the server side, and the check is here on the server side, always. If you really want to enforce something, it has to be done on the server side. Where is the server? Here. And the delete, here is the check, is TOTP, okay? Without this, the application is wrong, okay? You lose marks, points at the exam. Because, the server is the only one that can enforce the security rules, okay? And the rest is convenience, okay? So, this is less a problem than the check on the server. Check on server is about security. Here it's just about convenience. So, okay, it's true. I don't have the permission. The server will tell me it would be better to disable the button, but, if you don't disable it, it's not as big problem as the check on the server. So let's try just to make sure everything works. So 766-688. 766-688. Okay, and you see now it's enabled, so we can delete it, and it will disappear. Good. And did we do everything? Okay, the fetch for the TOTP API, last thing, but it's already there, otherwise nothing works. But I want to show it to you as well. So every time you have a new route on the server, you have to update the API.js file, right? So there is a login credentials, we already did it. There is one for verify TOTP, TOTP verify. It's a post API login TOTP. That's the name I chose for my application. Okay? Fetch, URL, login TOTP, method post. Credentials include, of course, the session has to be sent with a cookie and so on. Stringify, simply the code is fine. Okay? Just decide the name, code is perfectly fine. And on the other side, you have rec body code. Okay? That's all. So, we finished the implementation, right? So, I would say once you have the authentication, the rest is pretty simple, right? So I don't store the DB, so you have the original version, and just store the, save, commit the implementation that we finished here. Did implemented TOTP. Okay, I'll push so I don't forget, and that's all. That's the topic for the labs, not next week, but the week after. But I will publish the labs today together with the solution of Tuesday's lab. And where is the schedule? So you can start working on them, and basically you can also just use the labs as as a moment where you can come and ask questions on about anything about the course, okay? So let's finish with some security considerations. It shouldn't take that much. And slides. So, I mean, as you see, not so many slides, but I want to tell you a few things that just, in my opinion, actually, in the teacher's opinion, with my colleagues teaching in the same course of study and so on about cybersecurity, want you to know. So, of course, we talked about session IDs, we talked about cookies and performing operations which are risky, which needs to be protected, and so on. And I mean, there are a lot of things that can go wrong, and basically security nowadays is sort of going in the direction of adding, mechanism to ask you to do more things as a user, to make sure that only the actual, the user that is supposed to do the action can do the action, like the second factor authentication we just saw before, okay? So, regarding secret information, okay? So session IDs, cookies, tokens, and so on, needs to be protected as much as possible. So please, again, this part of the lecture is basically saying don't use any method that we didn't show, okay? Or it's not trusted in the literature in OWASP and so on, okay? So limit access to the secret information as much as possible. Here we have some limitations in the course. I need to show you something. I don't want to come here with 3 computers, or I don't want to connect to to a server somewhere else. Maybe one day we can do it, in future versions of the course, I don't know. But then if there is no network connection, we cannot test anything, right? Here, network connection is not always good, right? But anyway, we need to limit the access to secret information as much as possible, okay? In real applications, in production applications. So, for a cookie, cookies are very sensitive information. Just use the browser cookie storage. Don't use any other storage that is present in the browser. There is another storage I'm going to tell you in a minute. Don't use it, okay? It was born and was developed for other purposes. Use always the HTTP only flag. It makes much more difficult to, basically impossible to steal information through JavaScript, okay? Such information, so just a cookie, of course. Use the secure flag so the browser knows that it should only send the cookie on encrypted channels, okay? And unfortunately, we are not doing it ourselves because it requires a complex setup, okay? Here in the examples and at the exam. But sometimes it's not possible, right? Because if the info is to be sent via some JavaScript methods, like HTTP headers, when we have other tokens which are not just a cookie and so on, this is not always possible. So we need to store it somewhere, but please, please don't use the web storage API of the browser, because this is not a secure location, okay? There are 2 storages inside the HTML5 web storage APIs. One is called session storage and the other is local storage. It's used by many complex applications, like for instance Google Docs and these kind of things, because they want you, they want the application to be able to store something locally and then synchronize later when the connection comes back, because sometimes you don't have the network connection, but you want to still be able to operate in your application and so on. So that's a good use case. That's not a good use case for security information, okay? Because local storage and session storage, of course, persist even when the browser is closed and reopened, and session storage does not persist. But the point is that it is accessible by any application running on the browser, okay? Don't do that, okay? Because it's available in JavaScript through the window object. Basically, you have other attributes that we didn't talk about like local storage, session storage, and so on, where you can use to access and store information. And sometimes it's convenient because, like in a complex application like a Google Doc, you type stuff, you don't want to lose what you type, and if there is no network connection, maybe you can temporarily store the information in this local storage. Okay, so if you, in case you reload the application and so on, you can retrieve this information. But this is not for security. Security sensitive content, okay? Because a single cross-site scripting vulnerability can be used to steal all the data and load all the data and also put malicious data inside those storage, okay? So the data that you put, that you have inside this local storage and session storage cannot be considered trusted, okay? The cookie is, because it's a separate storage, it's managed differently. You cannot write directly inside the cookie storage. I mean, not normally, I would say. I mean, you need to have a server that stores the cookie, okay? Otherwise, I mean, and there is no point in storing information in the cookie storage, because if it's not a valid session on the server, it's useless, right? While if you store information in the session storage, in the local storage, that can be used to do cross-site scripting, because maybe the application expects some information to be safe, loaded, and be used in the rendering of your web page. Okay, and you already saw, and we already saw together, that we can have there are dangerous functions in JavaScript that can be used to perform cross-site scripting attacks, okay? You remember the story about source sinks and so on, which is safe, not safe, and that we need to be careful what the browser interprets as HTML, as JavaScript code, and so on, okay? So, in short, recommendation about security: never use session storage and local storage in your application for security-sensitive information. Okay, that's one point. Because, I must admit that, we didn't discuss this stuff in the course, but, cookies are a way of implementing sessions. They are not the only way. I was discussing it with one of your colleagues, asked me during the break last time. Can we implement sessions using tokens that are assigned payload and so on? Yes, we can, but it's not a cookie, it's not managed by the browser, and it comes with a lot of security implications, including the fact that if you want to revoke it, you need to have a blacklist on the server and so on. So, the point is that it's sent and manipulated by JavaScript differently from the cookies, okay? And it's only sent when it is required, which is good, okay? But it can be accessed by any malicious script in the page, so it's vulnerable to cross-site scripting, while if you use a cookie which is HTTP only, it's not vulnerable to cross-site scripting, because it cannot be accessed by any JavaScript code, regardless of where it comes from, not even from our JavaScript code, okay? So, it can be made to be sent on secure connection only, while, tokens and stuff, it's up to you to decide if you want to send it or not through JavaScript. Adding it as headers in the fetch, in short. A disadvantage of the cookie, and we are going to talk briefly about this now, is that it is always sent for any request. You remember that we said it's managed by the browser. Since the browser doesn't know if you need it or not, it means that it is always sent. If you match the host name and the path, the browser sends the cookie if the cookie set is not expired. Okay? And that can be a problem. That's the way in which phishing attacks work. They give you a link, you click on the link, you automatically open the browser has this cookie set, valid cookie set, and it sends it to the server, and that's a problem. While here, if it's sent only by JavaScript, you control when you send it. So in principle, you can avoid sending it if, the loading that page didn't come from a path that was sort of validated through your application, okay? We are going to discuss it in a second. Okay. Before that, don't forget to use the encrypted channel. So it means basically nowadays using HTTPS, let me call it them connection, even though the connection is TCP, right? But I mean, just to understand, HTTPS, it means that there is an exchange at a lower level that checks the server certificate, establishes a key for encryption, and it provides, an HTTP connection provides confidentiality. It means that people, I mean attackers, anybody looking at the traffic from your computer towards the server and vice versa in the network cannot see the data passing, okay? Cannot understand the data. This includes also other applications, you know, on the same computer, okay, including the server and the client. Because when the information leaves the application, it's already encrypted, okay? So I cannot just open a Wireshark, for instance, or some other network analysis tools here on the computer and see the information passing. That's why I'm always looking here in the inspector of the browser, because that's the only place where I have the possibility to see what's happening. Here it's clear text because it's HTTP, but if it's HTTPS, that's the only place where you can know what's happening, okay? Because you are at one end of the communication channel. Okay, good. It provides integrity as well. So reply request toward the server doesn't work because, I mean, you cannot just simply take the encrypted traffic and send it a second time toward the server because it's not recognized as original, okay? So it's not like paying twice, it's possible, just because you take the encrypted traffic and you send it back, you send it again to the server, okay? And it's provide authentication as well if you check the server certificate, okay? And most of the browsers nowadays check the server certificate in the sense that the server certificate has to be signed and has to correspond to the name of the host to which you are connecting. Otherwise, a big warning comes out saying, I mean, this is supposed to be bank.com, but the certificate is for attacker.com, okay? This is out of the scope of this course, but I mean, this is a functionality provided by HTTPS. Okay, it's not just a matter of having the lock. Okay, like what is it? The Polito, right? .polito.it, I think. Secure connection. Yeah, that's the lock and so on. But I mean, the point is that. You can check the certificate, right? And the certificate says the common name is polito.it, okay? So I mean, if you trust the certification authority, it means that, I mean, trusting the certification authority, the authority has given the certificate only to the owners of the www.polito.it, okay? Okay, good. How to configure HTTPS, that's a big topic, but I mean, we are not going to use it. But again, if you look at the OWASP, you find almost everything related to security, especially web applications, okay? Let me talk about this attack because this is really interesting to know. Actually, we already solved the problem because the second factor authentication already solves this problem, okay? At least for the login. We saw it for the login, but we can use it in any sensitive operation, okay? But, I mean, just for completeness, I wanted to tell you, I mean, how this attack works. So this cross-site request forgery, and how it could be prevented without the second factor authentication. But the point is that without the second factor authentication, we are still, I mean, subject to cross-site scripting attacks. So, I mean, nowadays, basically, nobody is using this kind of protection anymore because, I mean, if they want to really have some sort of good security, probably they need to have this second factor authentication enabled, okay? Okay, so let's see how this attack works. So there is an attacker, forges a malicious request link and sends it to a user. User way, email, put it into a forum where people is tempted to click, or it sends via through the social networks like WhatsApp, Telegram, and so on. And somebody clicks on the link opens the browser, and the browser unfortunately, has a valid session ID. So it has a cookie, and the cookie is sent automatically, as we were saying before, right? And this link says, oh, please transfer the money to this account and so on. Okay, so you're connected to the bank. I mean, we're always taking the bank because it's so nice example, because people understand money transfer when they should not happen and so on, but could be simply stealing information. Okay, I mean, send this, I mean, do something that puts your information in danger. Okay, okay, so you send this comment to the website of the bank, you have a valid session ID because unfortunately in the other tab of the browser you were logged in the bank website and so on, and so the attack is successful, okay? Because the request is validated by the session ID. It comes with the valid session ID, so the bank, I mean the website of the bank has no reason to think you are not the user that performed the authentication. Indeed you are. You simply clicked on a forged link. Okay, I mean, we could question the fact that, I mean, maybe this link should not be a GET and stuff like that, but I mean, in general, I mean, this could happen also because of cross-site scripting attacks and so on. This is the simplest case where you click on a link. When you click on a link, you send a GET request, so, I mean, not so much useful, but, you know, with cross-site scripting attack, you can send basically any kind of request you like because you have the fetch available in the browser. Okay, and so, I mean, the conditions for making a CSRF attack work is that, of course, the user must have an authentication session active. Of course, we don't know if the user has this session active or not. But, I mean, you post a link in a forum where there are 1 million people reading the post, and maybe just 2 or 3 have the session active, and that's possible, right? I mean, we don't know, but I mean, it's enough for the attacker. And the execution of a sensitive action relies only on the presence of a simple authentication factor. So, I mean, the server just checks if you have a valid session ID for the session, so the cookie, okay? And there is nothing else that the attacker cannot add because it is unknown. So, I mean, basically, just the fact that you sent a request using this, I mean, with the session ID, so this simple authentication factor is enough for the web server to execute the action, okay? And since, indeed, this cookie is sent automatically, but other things are not, I mean, we could think of mitigating this attack by means of using an additional token to be sent not in the URL, but as an additional HTTP header. And actually, it was done a lot of, I mean, a lot of times in the past years. That was named the CRSF token, anti-forgery token, request verification token, many names to do the same, to say the same thing. So there is a special value which is not sent in the URL, but as an additional HTTP header by the client to the server, just to confirm that the request comes from the client and not just because you clicked on some links somewhere or somebody has created a link without knowing how to add this additional piece of information, okay? So the point is, it becomes like this. So at login, of course, you provide username, password, you get the session ID, but you get also an additional piece of information. It's called CRSF token, or all the other names we saw. And this information is kept on the client side somewhere, okay? Not in the local storage, session storage, etc., but in the JavaScript memory. That's the only other place we have. Because it's not a cookie, and we don't want it to be a cookie. Because if it's a second cookie, it gets sent automatically, and that's not what we want, okay? As users to have a second cookie. And the server keeps the value and is associated to the session. So both the server and the client keep the value, and this is sort of random value generated at login time. And then every time you want to perform an action, you need to send this additional information, so this CRSF token, to the server. Otherwise, the server will refuse to perform the action. Okay? So don't store it as a cookie, otherwise it's sent automatically, and basically it has to be added manually by the client code, JavaScript, when you issue the fetch requests. Okay? We saw this object where you can specify credential, include the method, and so on. You can also specify additional headers. Okay, so you can modify the headers that are sent from the client to the server. And on the server side, of course, also with Express, but any other server middleware, allows you to read additional headers coming from the request. Okay? So, the server checks the token presence and value before proceeding with the operation that has been requested. Okay? The point is that this CRF token is in the JavaScript memory. Okay? So, if we have some cross-site scripting attacks, we cannot really do anything about it. But, I mean, if there are no cross-site scripting attacks, it's just like a phishing attack, they give you a link and so on, it works well. So, in short, it says, okay, post, transfer money, cookie, I mean, get, or whatever you want, cookie and so on, account number, etc., and there is no CRSF token, the website will refuse the request because it says, okay, it's missing the CRF token. Okay? So it's something additionally that is added by the code in your JavaScript application every time you make a request toward the server. Okay? Just to avoid the fact that you can create and forge a link that contains a request toward the server. Okay? And if you forge that link as an attacker, you don't have a way to add this additional header in the HTTP request. Okay? And so I would say that the website is protected from this kind of attack because it says, okay, there's no CSRF token, and so I will not execute the action. Okay? But I mean, it doesn't solve everything. And that's why basically nowadays, I would say, it's not so much used anymore because attackers find a way to circumvent this system because any successful cross-site scripting technique can defeat all CSRF mitigation techniques. If you have access to running JavaScript code, the JavaScript code that you want, you just study the code of the application that is to be the victim of your attack, and you understand which is the name of the variable that stores the token and so on, and you can execute some code that before issuing the fetch, it adds this token. So it doesn't solve anything in the end if you really have the possibility to perform a cross-site scripting attack. Okay, so that's the point. Okay, client-side CSRF attacks has also been developed recently and so on. So, I mean, it's also tricking the client-side JavaScript code to send requests by manipulating input parameters and so on. So the point is that we need to use a different approach because JavaScript is vulnerable, and how do we treat these cases? We just saw it, right? We can only treat these cases using multi-factor authentication at the moment, at least. Okay? The fact that you use a second factor that is not something you know and that is somewhere available inside your client JavaScript code, but it has been set in the past, like the secret, just set in the past, and you generate something which is one time, okay, like the OTP value. This is a very effective strategy in mitigating the problem of the cross-site request forgery attack. Okay, and any other cross-site scripting attack, by the way, that targets executing actions on the server, because it's something external. Okay, and it's one time. Or can be another factor that, in short, will send some information that cannot be forged by the attacker. Okay, the OTP is the easiest one to understand because we just saw it's time plus a secret value hashed in some way. And so, indeed, again, that's the same sentence we saw in the beginning of the lecture today, right? MFA, multi-factor authentication, is by far the best defense against the majority of password-related attacks, okay? And that's why it's so commonly used nowadays, because there are so many ways of doing attacks, and this, in the sense of sending forged requests to the server, that when we do something really dangerous, really sensitive in terms of security, transferring money, deleting things, let's say becoming administrators with much more power and so on, we want confirmation of the fact that the actual request comes from a client that is authorized to do the action, okay? One of these actions is the login. Okay, that's perfect, because after the login I can already do a few actions. But again, every time I want to perform a sensitive action, I can ask for an additional password one time. Okay, so it cannot be reused by an attacker. That helps me. That actually allows me to understand that the action is actually authorized, okay, by the user who knows the secret, okay? Good. So the point is that, we just saw the first line of this slide. Second factor authentication used at login time is good, but it does not address all possible scenarios. Indeed, if you just tried a few website, like for instance GitHub, when you delete a repository, that's one of the things that comes to my mind. Maybe the bank account, when you want to transfer money, we want to confirm the money transfer and so on, but that is something you do inside their app, so you don't really immediately see it's a second factor authentication, but in practice it is. They ask you to send a confirmation of the action you want to perform by sending a one-time password again, okay? Which of course is different from the ones that you already used. This is another use case. We will not ask for this use case at the exam because we didn't see here during the lectures. But you just need to be careful, because confirming action is something a bit different from logging in, okay? Logging in is, okay, I get a session ID. Confirming actions means that you send a TOTP code, that's good, but you need to make sure that that TOTP code is actually for the action you want to authorize, okay? So it's more difficult as a process than just logging in, okay? So you need to involve the action you want to confirm in the generation of the code, okay, to really make sure that the code works only for the action you want to authorize, okay? And that's why we have no time to see it in the course, okay, because it's much more complex. Okay, but we saw the principles. The important thing is that we know how to handle, one-time passwords, how they work, and in principle how we can use them. Okay. Okay, so almost done. But these are just final considerations about what we saw in this course. And I hope you got the idea from the lectures of this week and one of the previous week, that authentication, authorization problems are really complex problems and really delicate and sensitive, okay? In the sense that if you solve them in the wrong way, you're subject to attacks that have heavy consequences. And it's not just about cookies, not just about tokens, not just about CSRF, which is very, let me say, simple example of what can go wrong when you do authentication with cookies, for instance, which was the first way in which authentication was implemented. But you know that nowadays you can go to websites and say, okay, let me log in with Google, with Meta, with GitHub, and so on, with famous website where many users have a login, and so an account, actually, not a login, an account. And this exchanges, you know, tokens and information and security, and involves a security procedures that need to be well established and well tested, because if something goes wrong in one of the steps, that means that the system can be vulnerable to attacks, okay? And so if you want to perform third-party authentication, that's difficult, right? There are standards like Auth, or some like, well, some is not really for third-party, I think. And in general, if you want to have an authentication mechanism on one server and be authenticated or actually authorized, not authenticated, on other servers to do actions, that's a quite complex problem, okay? There should be other courses in this course of study of cybersecurity that talk about this, but I mean, you can search online for these keywords, I mean, especially OAuth 2. It's quite a complex standard, I would say. There are many different use cases and so on. But again, try not to think, well, this is probably too complex, I can do it this way and so on, because it's wrong, okay? I don't want to say 100% because you never know, but I mean, typically, if they designed something in a certain way, because a lot of people thought and discussed and tried to use this system, so it's well tested, and you should rely on these best practices to implement that form of security, okay? And you saw that there are so many possible attack approaches. We saw the cross-site scripting, and we saw the CSRF, I mean, today, and maybe other kind of attacks that will come out in the future. Even, I would say, social engineering attacks, okay? Let me spend a word about this that's not on the slides, but I mean, if somebody calls you on the phone and says, tell me your OTP, I mean, there's really nothing we can do about that, right? The problem is, as they say, layer 8, I mean, the user, right? I mean, if you're willing to provide the OTP code to anybody, I mean, you're probably willing to provide anything to anybody, okay? And so, I mean, implementing security, also in web applications, I mean, that is the topic of this course, of course it's difficult. And since it's so difficult and many things can go wrong and so on, just try to be updated and rely on the best practices, okay? Well-tested, standardized practices, and don't invent anything by yourself. And also, I mean, don't forget that you need to maintain your systems over time, okay? Because new attacks, new problems will be discovered. You need to patch the libraries because maybe there's something wrong in the implementation and so on. I mean, you cannot think that security is, okay, today I implement one thing and it will work forever, okay? It's not like this. It's like encryption and so on. It will be, I mean, somebody one day will break the encryption because it will have a faster computer, a different technology. We don't know, okay? So, the final advice I can give to you in this course is never invent your own mechanism. We don't like to see your own mechanism at the exam as well, okay? I mean, we will ask for simple things that we showed in the slides, okay, and during the course. So there's no need to invent anything. The only thing you might change, I told you, for instance, like for the second factor authentication, when you ask for the code, for instance, okay? You want to ask immediately after login, you want to ask it when the action is going to be performed, but this is still a second factor authentication for authentication, okay? So it makes the session more trusted. It's not for authorizing an operation. And so there are a few things that you can change and adapt to your use cases, I mean, compared to what I showed you during the course. And if you have any doubt, of course, feel free to come to the labs. You still have quite a lot of time, I mean, to test your ideas and so on. And we are willing to help you in the lab. And basically, these labs are not so much attended. I mean, if you give a feedback on this in the questionnaire, that's really welcome. If we should change the labs in another ways that is more useful for you and so on. But in general, try, I mean, to use something that we showed in the way in which we recommended to use it. It's not about making us happy. It's just because following well-established procedures and best practices is the way to achieve a reasonably good security in actual application when you will be going to develop this application in practice, okay? And yeah, don't forget to maintain the systems over time, okay? We know it's an expense. I mean, you're not the manager at the moment of the company, I don't think so, but of course, managers need to care about the balance and the money and so on, but the technicians or the engineers and so on need to make sure that the system works, including after the system has been developed, because it's to be maintained, okay? And basically, you need to make sure that weaknesses that are discovered over time are promptly addressed. That means software needs to be updated. And if you use standard library, well-maintained libraries, and standard approaches and so on, this effort is sort of minimized, right? You just check the new version of the library, does what you want, addresses the issue, you change it. Okay, maybe you do a little bit of testing just to make sure it doesn't break anything, and that's all, okay? If you invented your own system, you are on your own. You need to think if your system is secure to this new attack, what can go wrong, and so on. So spend a lot of time, which means a lot of money in terms of company view, that maybe they are not willing to do it, okay? Okay, so let me conclude with this also for the ones who see the recording. Please fill up the CPD JCT questionnaire, okay? Please do it, especially in the free text part. If you want to give any feedback, like you like the course, that's really nice, but I mean, something that could be improved, that's really welcome, and we care a lot about your comments, okay? We will meet again, not for the lecture, but for the lab, in not next week, but the week after. I will update the calendar when I'm back in the office. But there are 2 labs on Tuesday as usual, and on Thursday, so not next week, but the week after here in this room. That's the last lab of the course. Use it as you see it's useful for you. I mean, for asking any question about the program and whatever, okay? And we will meet still Thursday, 4th of June, for an example about how to design actually the solution for an actual exam text, okay? I will put this exam text online as well. Of course, you can go to the past years and check for the solutions and so on, but I invite you not to do it and try to reason by yourself, because it's, you know, it helps you maybe to design a better solution for your exam, okay? So if you have any questions or comments, you're more than welcome to ask. Otherwise, I think that's all for today. And yeah, remember to fill up the questionnaire and say it again and again. And